So, uh, I want you to imagine for a second that it is the year 2026.
Okay.
You're walking down the street in your city. Just, look around you.
Let me guess. Still no flying cars.
Unfortunately, no, there are no flying cars. Sorry to disappoint you there.
Yeah, we're always promised flying cars.
Always.
Yeah.
But if you look closely at the buildings around you, something radical has actually changed.
Right, because it isn't just the glass and steel anymore.
Exactly. It's the intelligence that's literally woven into the walls.
Yeah.
And, strangely enough, the dirt they stand on.
It really is a fascinating thought experiment because we tend to think of the future as this sudden, jump into science fiction.
Like overnight, we're in space.
Right. But the reality is that the revolution is happening right now. It's happening today in the blueprints and the databases.
Which is exactly what we are unpacking today on this deep dive. We have a massive stack of research here to get through.
A very heavy stack.
Oh, yeah. We've got a trend report predicting the state of architecture in 2026. We have insights on AI in construction management, guides on safety engineering.
And a really cool case study from a quantity surveying firm in Nigeria.
Yes, that one is super interesting. And I think if there is one thread tying all these completely disparate sources together, it's this idea that we are moving away from seeing buildings as just static objects.
They aren't just bricks and mortar anymore.
Right. The built environment is becoming this wild blend of high-tech data, deep sustainability, and, surprisingly, a much stronger human connection.
So I guess our mission today is to figure out how we get there.
Exactly. How do we get from a sketch on a napkin to a living building without, going bankrupt in the process?
Well, we're looking at a very complex ecosystem here, so we're going to explore this through three main pillars.
Okay, lay it out for us.
First, the technological explosion. So that's AI, BIM, and digital twins. Second, the return to nature.
Which sounds contradictory, but isn't.
Right, exactly. That covers biophilic design and adaptive reuse. And then third, the invisible business of building.
The stuff that actually gets it built.
Exactly.
Yeah.
Cost management, safety integration, and communication.
Okay, let's unpack this. I want to start with the digital backbone because I was reading through the Vectorworks report on 2026 trends, and the very first thing that jumped out at me was BIM, Building Information Modeling.
Mm-hmm. The famous acronym.
Right. Now, to me, before reading this, that just sounded like, 3D modeling, just making a pretty picture on a computer. But the report implies it's way more than that.
Oh, it is so much more than a pretty 3D picture. And we really do have to be careful with that acronym because people throw it around a lot.
But what is it really?
Think of BIM as a massive database that just happens to look like a building on your screen.
Okay.
A database.
Right. Because in the past, architects drew lines on paper. And if you moved a wall in one drawing, you had to manually go find that wall in the floor plan, then the elevation, then the electrical schematic.
And manually erase it everywhere.
Yeah. Which just sounds like an absolute nightmare for coordination.
It was a nightmare. It led to huge errors on site. But BIM changes all of that. You build a model, and that model actually holds data.
So if you move the wall...
The database updates every single view instantly.
Wow.
It updates the material list. It updates the cost projection. It's a single source of truth for everyone on the project.
And the report actually mentioned a stat that really stood out to me. It said 68% of professionals have already adopted this.
Yeah, the majority.
So this isn't even the future we're talking about. This is the baseline. But here is where the report gets really interesting to me. The AI part.
Oh, yeah, the shift is huge.
It describes AI not just as a tool for automating boring tasks, with what we usually hear, but as a quote-unquote creative partner.
That is a crucial distinction. We often fear AI is just going to replace human creativity entirely.
Right. The robots are taking our jobs.
Exactly. But the concept the source brings up here is generative design.
Yes. This blew my mind.
It's wild, right?
It really is. So instead of drawing the building yourself, you just tell the computer the rules.
You set the parameters.
Yeah. You basically say, hey, I need a building on this specific lot. I want this much natural light. I want to use these exact materials. And it needs to withstand this much wind.
And then the computer just spits out options.
Instantly.
It creates variations that you might literally never have thought of. It iterates thousands of times in a minute.
But the human is still in the loop.
Right. That is the key takeaway from the report. It does not replace the architect's judgment. It just supports the ideation process.
Because the computer doesn't know what feels right.
Exactly. The human still has to look at all those generated options and say, okay, this one works best for the community, or this one feels like a welcoming space.
There's also this tool mentioned in the stack called the AI visualizer. Have you seen this?
Yes, it's incredible.
You literally just type in a text prompt, and it turns your rough, messy sketch into a beautiful watercolor or a photorealistic image in seconds.
It really feels like we're giving architects superpowers.
Totally. You don't have to spend 3 days rendering a single image anymore. You just ask the machine to visualize it for you.
We are absolutely giving them superpowers. But we have to talk about what happens when the actual construction starts, not just the design phase.
Right, when the boots are on the ground.
Exactly. The source from Brick on AI in construction management has this really great phrase. They say, the training wheels are off.
I loved that line. They were comparing AI to a toddler that is finally growing up and entering the workforce. They keep talking about digital workers.
Yes. And to understand why these digital workers matter so much, you have to understand the construction business itself.
It's a tough business.
Profit margins are notoriously thin. A project manager might spend a quarter of their week just clicking buttons,
Just data entry,
moving data from one spreadsheet to another spreadsheet.
which sounds incredibly inefficient for an industry that moves millions and millions of dollars.
Yeah. It is incredibly inefficient. So Brick suggests that AI is evolving to handle finance, risk, and operations autonomously.
Autonomously.
Yes, these digital workers aren't physical robots out there laying bricks. They are bots inside the software,
Doing the clicking for you.
doing the clicking, but also predicting cash flow based on data that is literally 3 minutes old, not 30 days old.
Now that is a game changer. Because if the AI can flag that, say concrete prices are spiking in real time.
The project manager can react before the entire budget is blown.
Right. They can pivot immediately. Which naturally leads us to this concept of digital twins. This was another huge buzzword in the Vectorworks report.
It connects directly to this whole data idea we're talking about.
So a digital twin is exactly what it sounds like, right? It is a virtual mirror of the real physical building.
Correct. But the magic really happens when you connect the digital to the real world.
How so?
Well, you build the digital version first.
What?
Then you build the physical building. But then you attach sensors and cameras to the physical building that feed data continuously back into the digital one.
Wow. So if a pipe bursts in the real building, the digital building immediately knows about it.
Even better than that, the digital building predicts that the pipe is going to burst because the sensor picked up a tiny vibration anomaly 2 days ago.
That is wild.
It leverages data for the entire life cycle of the building, not just the construction phase.
It turns the building into a responsive living entity.
Exactly. Like it has a nervous system.
That is so cool. But, and this is the twist that really caught me off guard when I was going through the research today. While our buildings are getting smarter and more digital,
They're also getting earthier.
yes, that is the paradox, isn't it?
It's my favorite part of this whole deep dive. This is the second pillar of our discussion, the return to nature. The Vectorworks report calls it biophilic design.
Now, I'll be totally honest here. When I hear biophilic design, I usually just picture a tech office in Silicon Valley with a living wall and maybe a potted plant in the corner.
Right, a very expensive fern.
Yeah. Is it more than that?
Oh, it is much more. What you're describing is just greenwashing. True biophilic design is about fundamentally blurring the lines between the indoors and the outdoors.
Okay.
It's based on the scientific idea that humans have a deep biological need to connect with nature.
Which makes sense.
Right. When we box people up in drywall under harsh fluorescent lights, stress goes up, productivity goes down, people get sick.
So it's not just an aesthetic choice. It's directly tied to occupant well-being.
Absolutely. It's about maximizing natural light,
Yeah.
promoting natural ventilation, and using organic materials.
Speaking of organic materials, were you as surprised as I was to see a massive revival of rammed earth?
Oh, I was thrilled.
I mean, rammed earth sounds like something from the Middle Ages,
Yes.
or even prehistoric times.
It is ancient technology, but it's making a huge comeback for very modern reasons. The report highlights this specific project, the Oyaki Farm by Tono Mirai Architects.
Yeah, that project sounded absolutely beautiful.
It is. They used semi-fire-resistant wood, specifically cedar and cypress, and combined it with these massive rammed earth walls.
But why go back to literal dirt when we have modern concrete?
Because dirt performs incredibly well. Those earth walls provide what we call thermal mass.
Okay, let's unpack thermal mass for a second. What does that actually mean for you, the person living or working inside that building?
Think of it like a battery, but for heat.
A heat battery.
Right. The thick earth walls absorb the sun's heat during the hot parts of the day, which keeps the interior nice and cool.
Because the heat isn't getting inside, it's trapped in the wall.
Exactly. Then, at night, as the outside air cools down, the walls slowly release that stored heat back into the building. It regulates the temperature naturally.
So you aren't just blasting the AC all day and the heater all night.
You don't have to. It creates a much more comfortable, stable environment, and it massively slashes energy bills.
It's such a perfect example of how low-tech materials can solve high-tech problems, like global CO2 emissions.
And that connects perfectly to the adaptive reuse trend that the sources also talked about.
This seems like a massive shift in industry thinking.
It is. For a very long time, the adapt-up setting in construction was basically just demolish and build new.
Right. If a building was 40 years old, you brought in the wrecking ball.
You knocked it down. But adaptive reuse is about taking a historic structure, maybe an old factory or a forgotten warehouse, and reimagining it.
So instead of knocking it down to build a glass tower, you turn the old factory into modern locks or a tech hub.
Exactly. It honors the past of the city, but critically, it reduces waste. The most sustainable building in the world is the one that is already built.
That brings us perfectly to the carbon math, because the sources mention this tool called the embodied carbon calculator.
A very important tool.
I think most people understand general energy efficiency, like turning off the lights saves energy, getting better windows saves energy, but this is different, isn't it?
It is entirely different. Think of embodied carbon as the heavy backpack that the building has to put on before it even opens its doors to the public.
Oh, that's a good way to look at it.
It's the total energy required to mine the raw ore, smelt the steel, bake the concrete, and transport all of that heavy stuff to the construction site.
That is a great visual. So you could build a super high-tech, incredibly energy-efficient building.
But if you used materials that took a massive amount of carbon to produce in the first place, you're starting your project with a huge carbon debt.
Exactly. You might never actually pay off that carbon debt, no matter how efficient your smart LED lights are.
The calculator helps architects see that exact cost up front. It forces them to stop and ask, do we really need steel beams here, or can we use engineered timber?
It's literally like counting calories, but for the planet.
And with the 2030 climate challenges coming up so fast, doing that math is becoming mandatory, not optional.
It is. But let's shift gears a bit. We have designed this amazing high-tech nature-loving building. We've calculated all the carbon. Now we have to actually build the thing without the whole project collapsing into chaos.
Which brings us to the third pillar, the invisible architecture.
Right, the processes that keep everything standing up. We have this concept of integrated engineering design, and this came from the GDI engineering source.
This directly addresses a classic, very painful problem in construction. Usually you have an architect, a structural engineer, and an MEP engineer.
MEP being mechanical, electrical, and plumbing.
Right. And traditionally, they all work in completely separate silos.
So the architect draws a beautiful sweeping ceiling.
And then the MEP guy comes in and says, yeah, I need to put a giant ugly air duct right through the middle of that.
Exactly.
That is what we call a clash. And in the old way of doing things, you often wouldn't even find that clash until you were standing on the actual physical construction site,
With a pipe in your hand.
staring at a solid steel beam that is right in your way.
And fixing it at that point costs an absolute fortune.
Thousands of dollars and days of delay. So integrated design means everyone collaborates inside that BIM model we talked about earlier, right from day one.
So you see the duct hitting the beam on the computer screen months before you ever buy the materials.
Exactly. And you fix it by moving it with a mouse click. Zero cost.
And part of that early collaboration is safety. We have a source here from Budlong on fire safety engineering.
Very important stuff.
And I actually learned something completely new here. Fire safety isn't just about adding sprinklers.
No, and that is a very common misconception. Sprinklers are an active system. They only react to a fire that has already started burning.
Right.
But Budlong emphasizes passive systems too, things like fire-rated walls, smoke dampers, and the way the building is physically compartmentalized to stop smoke from spreading from one floor to another.
They call it fire prevention engineering.
Yes.
Which is really about stopping the fire before a spark even happens.
It's analyzing ignition sources early on. Where exactly are the electrical panels going? What kind of materials are being stored near them?
It's a proactive approach rather than a reactive one.
You are designing safety directly into the layout from the start, not just bolting it on at the end to pass an inspection.
Now let's talk about the actual bottom line.
Yeah.
Because you can have the safest, the greenest, the smartest building in the entire world, but if it costs $1 trillion, it is not getting built.
It will just remain a beautiful drawing.
Exactly. And we have a really fascinating case study for this from Quaron Consultants. They are a firm based in Nigeria.
I really appreciated having this source in the stack because it grounds all this high-level futuristic theory in harsh economic reality.
Sure. They focus on quantity surveying. Now, I will be totally honest, before reading this, I thought a quantity surveyor was just somebody who literally counted bricks on a site.
A lot of people think that, but they describe themselves as construction economists.
That is such a powerful and accurate title,
It is. Their job is value maximization, not just blind cost cutting. They manage the classic project management triangle,
which is time, cost, and quality.
the iron triangle.
Right, the Iron Triangle.
If you want the building built faster, it is going to cost you more money. If you cut costs drastically, the quality is definitely going to suffer.
So the quantity surveyor's job is to keep that triangle perfectly stable.
Yes.
The scale of their work really impressed me, too. They listed specific projects like the Flourish Residences.
Those are the residential blocks with that distinct purple and cream aesthetic.
Right. And then they also work on the Cardinal Stone office block and even heavy factory upgrades for Life Care Ventures.
It really shows the sheer breadth of the industry, because whether you are building a luxury residential home in Lekki or a massive industrial flour mill, the core principles of cost control remain exactly the same,
You absolutely need detailed bills of quantities,
which is basically the master shopping list for the entire building.
down to the last nail.
It is a highly granular list of every single screw, every bag of cement, every hour of human labor.
Because without that, you can't get accurate tenders from your contractors.
No, you can't. And in a dynamic, fast-moving economy like Nigeria's, having a construction economist ensuring you stay within that budget is absolutely vital.
It is literally the difference between a project that gets beautifully finished and one that just stands abandoned as a concrete skeleton.
Exactly. That financial discipline is the invisible foundation of the entire building.
So we have got the tech, we've got the nature, and we've got the math. But there is one last piece of the puzzle here.
You have to actually sell the vision.
You have to sell it. And engineers are notoriously bad at this, aren't they?
It is the classic engineer's dilemma.
They are so great at the math, they're great at finding the technical solution, but they often struggle to explain why it actually matters to a non-technical client.
They get completely lost in the granular details.
Right. We have a source from Content Beta that talks specifically about product demo videos. They analyzed how companies like Slack and Zoom sell highly complex software. And the key takeaway was basically, show, don't tell.
It sounds so simple on paper, but it is incredibly hard to execute well. You have to make the customer the hero.
The hero's journey framework.
Yes, exactly. Because in the engineer's mind, the product or the building is the hero. They want to say, look at my amazing, super efficient HVOC system.
But in marketing, the client is the hero.
The client has a problem, a dragon to slay, if you will. Maybe their dragon is operational costs are eating all my profits, or my employees are stressed and unhappy.
That's a great analogy. So the product isn't the hero. The product is just the sword you hand to the hero so they can slay their dragon.
Precisely. So for an architect, the client isn't buying a BIM model with integrated MEP.
They don't care about that.
They are buying peace of mind. They are buying a profitable, stable asset. They are buying a happy workforce.
That completely reframes everything. And this concept extends to email marketing, too. The OCP Academy source talks heavily about building relationships through email.
Yeah, moving far away from transactional emails.
Like, here's the invoice, or please sign this form.
Right. Moving from that to actual relationship building.
They suggested strategies like sending regular project updates, detailed case studies, or just interesting technical insights.
Engineers really should act as educational guides for their clients. If you send a client a breakdown of a brand new fire safety regulation and explain clearly how it affects their specific business, you're building immense trust.
You're showing real value before you even ask for a check.
So when they need a new project in 6 months, they don't go on Google and search for engineer. They check their inbox for that firm that has been helping them all along.
It is all connected.
It really is.
The AI helps design it. The quantity surveyor counts the cost. The fire engineer protects it. But the clear communication is what gets the contract signed in the very first place.
It is a holistic ecosystem. You simply can't just be good at one part anymore. If you ignore the carbon math, you fail regulations.
If you ignore the AI, you are way too slow.
And if you ignore the marketing, you have zero clients.
So let's synthesize all of this. We started by imagining 2026. We now have AI acting as a creative colleague, generating designs we couldn't even dream of on our own.
We have buildings that are literally returning to the Earth with rammed Earth and biophilic design principles.
We have a digital nervous system made of digital twins, and holding all of it together are the invisible forces, the integrated design, the proactive fire safety strategies, and the construction economists watching every single penny.
And all of that complexity is wrapped up in a clear narrative, a story told to the client that puts them right at the center as the hero.
It is a lot to take in. Honestly, it makes me look at the construction site down the street from my house very differently today.
It's not just noise and dust anymore.
No, it is a massive, highly coordinated data operation.
It absolutely should change how you look at it. And, there is one final question I want to leave you with after all this research.
Lay it on us.
We talked so much about AI generating these perfect designs and digital twins managing the building's daily operation. If the computer can design the optimal wall, and the computer can tell you exactly when to fix the pipe.
What is the future role of the human architect?
Exactly.
That is the million-dollar question. If the bots are doing the drawing and the math, are we just obsolete?
I don't think so at all, but I do think we are seeing a fundamental shift in the profession. The human is no longer just the designer of walls. They are becoming the designer of systems.
The designer of systems, I love that phrasing.
They are the conductor of this massive orchestra of AI, nature, and data.
Because the AI can optimize a building perfectly for wind resistance, but it can't understand human delight.
It can't understand the feeling of home. The real value isn't in manually drawing the line anymore. It is in knowing exactly why the line should be there in the first place.
So the tools change. They get vastly more powerful. But the vision, the core human need for shelter, for safety, for beauty, that stays exactly the same.
Precisely. The human element becomes more important, not less. Because we have to guide these incredibly powerful tools toward a result that is actually good for people and the planet.
Well, on that note, next time you walk past a construction site, take a peek through the fence.
Yeah.
You might not be able to see the AI or the carbon calculations happening, but they are absolutely there, building the future right in front of us. Thanks for joining us on this deep dive.
It's been a real pleasure.
See you next time.